Hey everyone, thanks for tuning in. Today we're going to be looking at the gradient of parallel and perpendicular lines, okay? So hopefully you should know what parallel and perpendicular lines are, and this lesson I'm just going to be relating them to their gradient. Although it's alright if you don't know what parallel and perpendicular lines are, I will still briefly run through what they are and what they basically mean. So first off, we're going to be looking at parallel lines. So two lines are said to be parallel if they just never meet, okay? So they essentially, it's just the same line, just shifted like left or right or up or down, okay? So in terms of their gradients, we say two lines are parallel if their gradients are equal, okay? Namely, if m1 equals m2, where m1 is the gradient of one line and m2 is the gradient of another, okay? So consider the blue and green line here. They are said to be parallel because they never meet, okay? But if we relate it, or at least try to relate it to their gradients, okay, hopefully you can realize that the blue line is going, if we consider, from a certain distance on the blue line, okay, so from this point here, let's say, to somewhere over here, okay, so by this distance, we are rising by a certain amount, okay. Now, on the green line, if I consider that same distance, alright, I will rise by the same amount, okay? So this basically means because they're rising and running at the same amount, they will never meet, and this then explains why their gradients are equal, because gradients are defined as rise over run, okay? Next, we're going to be looking at perpendicular lines, okay? So two lines are perpendicular if they meet at 90 degrees, okay? So they intersect each other, and they intersect each other in such a way that it makes a right angle where they intersect, okay? Now, if we're relating it to its gradient, we're saying that take the gradient of one of the lines, multiply it with the gradient of the other, and we will get -1, okay? If this is satisfied, then the two lines which we're considering are perpendicular. Now, if I want to rearrange this equation to something like this, okay, so this is basically saying if I know one line's gradient and I want to find the gradient of a perpendicular line to the line I know, then I can say, well, the gradient of the line I want to find is -1 divided by the gradient of the line we know, okay? So in other words, we can say the gradients are negative reciprocals of each other. This means if you know the gradient of a perpendicular line, you can reciprocate it, so you can flip the fraction and just pop a negative out the front, okay? So we'll look at some examples of these, but just to briefly explain what this means, the negative reciprocal, we can have a gradient of, let's say, 3/4, so 3/4. The perpendicular line, so the gradient of the line perpendicular is, well, we reciprocate it, so we flip the fraction, it's going to be 4/3, and we pop a negative in front, so like that, okay, so -4/3. And let's say we happen to start with -4/3, then we'd reciprocate it to -3/4, pop a negative out the front, and we get a double negative, so it becomes +3/4, okay? So these work in both ways. And if we multiply these two, then we're going to be getting -1. So if a line had gradient 3/4 and another line had gradient -4/3, they would be perpendicular lines. Now, in case you are unfamiliar with what perpendicular lines look like, this is just an example of two perpendicular lines. So as we can see, these are our two lines, and when they intersect, the intersection contains a right angle, okay? As a matter of fact, all these will be right angles, okay? So let's get into an actual example. So this one's perhaps harder than the second one, mainly because it's just more applied. But we need to show that the diagonals of a quadrilateral ABCD are perpendicular, where the vertices of that quadrilateral are A, B, C, and D, okay, and they each have coordinates, okay. So I need to show that the diagonals are perpendicular. Now I have a quadrilateral, okay, so let's just briefly sketch out what this quadrilateral is going to be. It's just going to be something with four sides, like four straight lines, so ignore this curve, okay, this should actually just be a straight line instead, okay. And what I'm saying is that this is A, B, C, D, A, B, C, D. And what I need to show is that their diagonals are perpendicular, namely this is perpendicular to that in such a way that this angle here is 90 degrees, okay? Obviously this particular example isn't, okay, but that's mainly because first off, it's not to scale, and second, it's hand-drawn. So the moral of this is just to kind of visualize the example. And so what we can hopefully see is that we're going to be considering the gradient of the line AC and the gradient of the line BD, okay? And yeah, and then we need to use those gradients to show that they're perpendicular. So what we're going to do is we're going to start with the gradient of AC. Okay, so I'm going to start down here, and the gradient of AC. Now remember, gradient is rise over 1, or more algebraically, it's going to be y2 minus y1 over x2 minus x1. Okay, so if we consider AC, we've got y2 minus y1. Oh, let me just focus this. It's going to be negative 3 minus 7. Okay, so let's pop that in there. Negative 3 minus 7 over x2 minus x1, which is negative 2 minus 3. Okay, so minus 2 minus 3. And that just gives us negative 3 minus 7 is minus 10 over minus 2 minus 3 is minus 5. And that just simplifies to positive 2. Now if I consider the gradient of BD, yet again, y2 minus y1 over x2 minus x1. So 0 minus 6 over 11 minus minus 1. Okay, so it's going to be 0 minus 6 over 11 minus minus 1. So 0 minus 6 is negative 6. 11 minus minus 1 is 11 plus 1. So that's going to be 12. And if we simplify that, it gets us a negative half. Now if we consider the gradient of AC and times it with the gradient of BD, what we're going to get is 2 times minus 1 over 2, which is equal to negative 1. Okay, therefore, by definition, they are perpendicular lines. Okay, and from this, you can then conclude that the diagonals of this particular quadrilateral are indeed perpendicular. Okay, so the next example that we're going to be looking at deals with parallel lines, but is probably a little bit easier. Okay, so we're saying the interval joining the points points C and D, where C is negative 6, 0 and D is negative 1a. We're saying that interval is parallel to a line with gradient 10, and we require to find the value of a. Okay, so first off, we're going to start with the gradient and reciting the definition in that it's y2 minus y1 over x2 minus x1. Now, why am I going to be using the gradient formula? I'm going to be using the gradient between these two lines, and I'm going to be saying that it's equal to 10. Why is that? Because it's a parallel line, and remember, parallel lines have equal gradients. So the line which joins C and D has a gradient parallel to 10, which means its gradient indeed is 10. Okay, so 10, which is the gradient, is equal to y2 minus y1, which is going to be a minus 0 over x2 minus x1, minus 1 minus minus 6, so minus 1 minus minus 6. So 10 is equal to a over minus 1 minus minus 6 is it's minus 1 plus 6, which is 5. Alright, and then times by 5 on both sides to get a, in which is 50. Okay, and that's about it. That's really like just some one-off examples with perpendicular and parallel lines. We can, the questions which you're going to get from here probably are going to be a little bit more applied and mixed in with some other questions, like dealing with maybe angles of inclination or distance and midpoint that can kind of relate it to that in a weird way. So you never know. But as long as we're strong with the basics and strong with the definitions and what everything means, then we should be pretty good. Okay? So I hope you learned something today. Hopefully it wasn't too difficult. And yeah, I'll leave you with that. Enjoy.